Well, hello and welcome YouTube. Mr. Robbins back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and privilege to be serving you today, as it is every day here in my virtual classroom. And step out inside, and while I say it's all math-based, it's a lot less math and a lot more murder. You see, we are going to be talking about proofs, proving things, proving people guilty of murder, perhaps. I like to use that analogy a lot because people understand it. People understand murder. No, people understand the idea when you talk about court cases and stuff. And listen, I've never sat in a court case thing in my life. I've only seen them on movies. But I like to glorify, not in a good way, I like to glorify the idea of what it might mean and tie it in akin to when we do proving triangles congruent. I think people understand the analogies that I make, even if it's not exactly the hard case way that it's done. Now, this isn't a series of any other videos that I've done, although I might be doing some reviews later involving proofs themselves in a bit. What I'm going to do is run through a worksheet that has a lot of pre-built proofs, ones that a lot of them are fully, the first three are fully complete, the other ones are partially completed and will fill them through. But I want people to get the understanding of why proofs exist the way they do, what kind of documentation is there, and the vocab that's being used. Now, each one of these proofs also involves something at the end called CPCTC, and I'll dive into that not later. I'll dive into it meanwhile. It's going to be the last step in all these things here. I guess it's part of a highlight of the worksheet. I just want to show that it exists. It can have a tie-in with the murder aspects of them as well. But this is all about proving the triangle's congruent too. You don't use CPCTC unless you prove the triangle's congruent first. And I guess that's the highlighted portion of it. So I think I need to make a dividing line between the second to last step in every proof and the last step in every proof and say, here's where you might stop based on the statement. And here's where we'll continue forward. Okay, so before I actually show you the worksheet here, which there'll be 3 pages worth, like I said, the first 3 problems that we do are fully completed already. What I'm going to do is just kind of show what the documentation is saying and how you lead from one step to the next, because everything needs to be justified with hard evidence. And you're going to see that hard evidence in short amount of words. And some of those short amount of words, you have to know what they mean. And we're going to get a diagram in all of them. So let's go ahead and get started with this thing. So this first sheet right here, the first portion. Looking at this first box right here, this is the problem that's provided to you. You are first going to be given information. It's either going to be stated and or drawn. The drawing can also assist with that given statement, and that drawing can sometimes provide some of the given statements. You see, if you want to prove somebody of murder, you can't go off nothing. You can't just say, prove somebody a murder. I need a name. I need a face. I need a body. I need something to get something started off of, right? I need a location. What are we talking about, right? You need something to go off of. So, and sometimes those somethings can lead to other somethings, or sometimes those somethings can be the pieces with the other things you find on your own to lead to that final evidence, and therefore he did it, kind of thing. Now, this given thing right here talks about segments being congruent to each other in 2 different triangles, and then we see the connection in these triangles in a very, this is going to be the easiest triangle congruence proof you would have ever seen in existence, because they give you everything off the bat, everything's drawn and oriented the exact same way, and your final statement can be the proof in and of itself. A triangle congruence proof has to be a minimum of 4 steps if all the givens are separated, because you need at least 3 bits of information to prove triangles congruent, and I'm going to get into that in just a moment. So we are given that segment MN is given as a congruent segment PQ. So we do 1 tick marks right here to indicate that they are congruent. Do I know what their actual measures are? No, but if one is 4 inches, the other's 4 inches. You know what I mean? That's what they're telling you there, and that's all we need to know. Segment NO is congruent segment QR, so you see that right here and right here. And they do 2 tick mark things to indicate they're congruent to each other and not necessarily congruent to these. In fact, they might be uniquely different from them. This may be a scalene triangle and not isosceles or equilateral. And then segment OM, is congruent to segment RP right here. So 3 tick marks to again indicate those. And you can totally tell that they correspond in the way that they had them face the same direction. That is not something you always get the luxury of doing. Of having. We need to prove, now they're asking us to prove that angle M is congruent to angle P. They want us to show this right here. And I'll tell you what, if you're not doing the CPCTC route, normally they'd say something like prove like this triangle, this statement right here. Prove triangle MNO is congruent to triangle PQR, and then you'd be done right there. That's what the majority of triangle congruence proofs do. What we're doing is the step beyond. So let's draw that line separating the second to last step from the last step here. I'll kind of do a dotted line right there. It's not to say there's anything wrong with the bottom one. It's just it's going to exist in every problem, and some people might not be too focused on that right now. Let's focus one thing at a time. The documentation of this thing is as such. Generally, what you want to do is lead off with givens. It doesn't always have to be all the givens. You have to lead off with whatever givens you think is going to help draw you into future statements and conclusions. But there's nothing wrong with and being healthy with starting off with givens. You make a statement, you justify it. We know this is true because it was told or shown. We know this is true because it was told or shown. We know this is true because it was told or shown. You have to justify it. That might sound bland, that might sound tedious, that might sound obnoxious, but it is, I don't know if documentative is a word, but it's formal. It's formal. It's formal documentation, and that's what we're doing. And it's going to help us lead into our thing. We just proved all three sides in two different triangles are congruent to each other. Does three sides proven congruent to each other, or is showing three sides congruent to each other in two different triangles absolute hard evidence? Is that enough information? Is that sufficient to say that even if you don't know any of the angles are congruent to each other, that these triangles are congruent to each other, meaning that they are absolutely the exact identical triangles? You couldn't have any different triangles with just those three bits of information? Yes. There are five. But in non-right triangles, there are four different reasons we can justify that two triangles are congruent to each other, given only three bits of information that would show they're congruent. One is if you knew all three sides were congruent to each other. Another is, and we'll get into them when we see them, if two sides are congruent to each other, not two sides, but two sets of corresponding sides in two triangles, and the angles in between those two sets of sides are congruent to each other. A third one is two sets of angles congruent to each other, and then a side in between. And then a third is two sets of angles congruent to each other and a side outside of it. There's another one called HL, which stands for hypotenuse leg. That means in a right triangle, if the two hypotenuses were congruent and if one set of legs were congruent, then that is enough information. Notice what is not on here are anything that are two letters only. Notice that angle, angle, angle is not on here. And notice that angle, side, side is not on here. Now, I have some lecture videos that cover all this stuff right here, but probably not in the two-column proof format. So I'm not going to dive deep into this. But these are not on here because there are ways that you can draw two or more different triangles that says just because all three angles are congruent to two different triangles does not mean those two triangles have to be identical in size and shape. It doesn't. And same with angle, side, side right here. Not a guarantee, except for in HL. This is an exception to the rule for various reasons, which I won't get into here that I have in another video. Bottom line is, if you can document and show that all three sides in a triangle are congruent to three sides in another triangle, then you can build that case to say, because of statement 1, 2, and 3, and I promise I'll go faster after this, because statements 1, 2, and 3, yes, these two triangles are congruent to each other by side, side, side. Now, segments congruent to each other means the segments are identical, blah, blah, blah. But triangles being congruent means that all 6 parts of those triangles are congruent to each other. All 3 sets of sides and all 3 sets of angles. We didn't know that the angles were congruent to each other before we proved the triangles are congruent to each other. But because we proved the triangles are congruent to each other, that means any sets of angles that correspond to each other will also be congruent. As a result of that, because of statement 4, that helps us lead to statement 5. If the triangles are congruent, then corresponding angles are congruent, such as angles M and P. That's what CPCTC stands for. It stands for corresponding parts of congruent triangles are congruent. M and P correspond to each other. How do we know? Is it because they face the same direction? Sort of, in the way that the corresponding parts all face the same direction here. So I guess these left side angles do correspond. But it's also from our triangle statement. You know, what's going to be a healthy practice for us to do today, which is nice because they don't have us prove the triangle's congruent, which means we have to come up with this statement on our own. unless it's pre-filled out, is the letter ordering that you write is totally going to matter. And I don't need to say this many times here, but letter M and letter P must correspond if you're going to write them as the first letters together. And if they are both the first letters, then they should correspond. That's why they are congruent to each other. That also means angle N is congruent to angle Q, and angle O is congruent to angle R. And that does seem to match up right here when you look at it right here. So you're going to get this good, healthy practice of seeing what that looks like. We only needed to prove this one, not the others, even though the others must be true. I am going to move on right after this, but if I do link that whole thing to murder, it's like, you know, and I'm not good with examples because I can't think of them on the fly, and they're not good ones, but you're trying to prove someone guilty of murder, and you're like, all right, I want to get this evidence. And by the way, the whole thing about side, things like that is you don't need to know every shred of evidence in the world to convince a jury that someone's guilty of murder. You need enough, and whatever that enough is, obviously needs to be enough. I was trying to see how deep that hit was. It honestly needs to be enough to be that thing, but you don't need everything under the sun. But you try and get everything under the sun, right? You try and get as much as possible. And you're trying to say, oh, if only I could pinpoint the location of him and her at this time of day, you know, like this would be I don't know if it would be a slam dunk, but this would be good hard evidence. If only I could know that M and P were congruent, you know, that would have been really damning, right? That would have really helped me for my case if I knew they were congruent. But I can't find that out. I can't put them together because reasons, right? I don't have witness. I don't have alibi. You know, I don't have these scenarios to say for sure. Now, what I'm going to do is I'm going to find other bits of evidence. The blood, the weapon, the DNA, the da-da-da. I'm going to find all these other bits of evidence, and I will convict him of murder. And when I do, I guess, therefore, that does mean the fifth thing. If he did murder her, blah, 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 therefore, I guess that means the other thing's true. Is that part more important for this thing? I guess not more important than murder, because that thing led to the murder. Maybe it could lead to the fact that, oh, then he murdered her too. Then it was a double homicide. Because here's the thing about CPCTC. This actually starts leading you to other things that you can do. We use triangles as a basis for things of like quadrilaterals, like parallelograms and kites and rectangles and squares. And this CPCTC helps build these other properties of those shapes. It's a really important tool that goes to future parts, but because our practice is currently only on triangles, this will be that. All right, I spoke a lot on a single problem. I will go a lot faster outside the exception of teaching you new things that haven't been shown in this previous one. This next one, given that segment SU is congruent to segment UV as it is marked right there, let's prove that segment ST is congruent to segment VT. Now I will separate this thing again once more, and I will state that I think this proof is actually really missing some statements. I already told you before that you really need 4 statements to make a proof, a triangle congruence proof at minimum. I feel like they're really missing something, which is it's given right here, and you can say it a bunch of different ways, I suppose, but you should really be documenting it, which is some form of either saying this line is perpendicular to this line, or the statement after, which could say this is a right angle and this is a right angle, or to say that these two are congruent because all right angles are congruent. Bottom line is they're missing a case that should somewhere at least get to the point that says angle SUT is congruent to angle VUT. You could, based on the drawing, almost say probably that it's given. You could kind of say that it's given if these markings were here because all right angles are congruent, but you can also lead backwards from those other things. Because of perpendicular lines, you have right angles. Because of right angles, you have congruence. Somewhere, though, this should have been mentioned. Somewhere this should have been mentioned here. And I'll go one step further. This isn't my worksheet. I'll go one step further. This is an HL. I'm just going to go ahead and say it right now. This is an HL. I'm already not a fan of this proof. Now I'll go a third step further. I really should have paused this whole video because this isn't correct either. Okay, now that I'm looking at this thing, this isn't good documentation. All right. This is not a good lawyer right here. All right. Let's try and move on with what they said though, because there is something nice that we have to talk about here. It's a new thing. They said TU is congruent to TU. Now they are referring to this segment right here, and I'm going to put a double tick mark there to represent that. Why are they saying that a segment is congruent to itself? Well, what they're really talking about, imagine my hands here, what they're really talking about are a segment TU in one triangle and a segment TU in the other triangle that are merged together as a single. You're seeing it as a single side, but if separated, they could represent different sides. But the point is, any side that is shared for two different triangles, it's the same thing in both of them, right? Because you can see it together. So split, you might see it as it's congruent to itself, but what we're saying is the segment in one is congruent to the segment in the other. It's called the reflexive property. It is in reference to shared, not properties, but property. It's in reference to shared sides or angles potentially, but shared sides in two different objects are congruent to itself. So TU congruent to TU right here. So what we do have to now do, assuming that you had this one, and this one, we now have enough information to say that these two triangles are congruent to each other. Which one of these does it fit? Side, 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 angle, angle, side, or HL? It's not HL because although HL exists in right triangles, it's about a set of hypotenuses congruent and a set of legs congruent. We don't have the hypotenuses congruent. We don't know that. In fact, we're trying to prove that the hypotenuses are congruent to each other. It's definitely not HL. No. Instead, it's going to be, let me kind of erase this by wiping out that statement they had. Instead, we could say triangle, and I'll just say what I said here. Triangle SUT, here's where we get to good practice. Triangle SUT is congruent to triangle VUT right here, VUT, by side angle side. It's by side angle side instead. And, the reason for that is because the way that they mention this order here is two sets of sides congruent in these two triangles, side and side with side, side. And the angles in between are congruent as well. I don't care if they're right angles or 89-degree angles or 1-degree angles or whatever they are. They're congruent to each other. It doesn't matter if they're right angles. That doesn't make it HL. It's just side, angle, side with side, angle, side. Two sides congruent and the angle in between. And that's what this is here. The problem with what they wrote before in this portion is parts didn't correspond. Notice how S corresponds with V. See this as kind of a reflection here. S corresponds with V. The segment goes to U right there that are the congruent right angles up to this T tick mark, SUT, VUT. So does order matter in the first triangle that I write? Could have I written TSU? Of course I could have. My other corresponding one would have had to have been TVU though. So can we prove that ST is congruent to VT? Now, as a result, can we say that, hey, therefore this side must be congruent to this side? Well, yes, and it's important when we say CPCTC as the reason, it wasn't just that we proved the triangles are congruent, it's that when we wrote the statement, it showed the parts corresponded. Segment ST, the letters S and T for me are the first and third letters here. Segment VT has V and T as the first and third letters here. In these congruent triangles, these parts corresponded, therefore they are congruent. So that statement did indeed lead to that one after this. So I didn't love that they were missing this. Of course, they had number 3 completely wrong, and I'm saying they. I don't know who they are, but I'm going to have to go ahead and fix things, it seems, along the way. This is something I gave to my students, and I said, hey, it's already a little filled out. We can play with it, but it has some problems. All right, and you know what? And I remember doing another thing that had problems with my kiddos before. I'll address that typo as well. That's okay. Okay, number 3. Now after this, we're going to have to fill out some on our own a little bit. Given segment AB is parallel to segment DE, C is the midpoint of segment AE. Let's prove segment BC is congruent to segment DC. Now remember, let's do the triangle congruence part first and then get to the end, which is always the part, do the parts correspond, So we'll get there. Okay, first of all, it was given, no. What they wrote, okay, this is typo after typo. This is a problem. It was given that segment AB was parallel to segment DE right here. So that given is actually represented here. These aren't tick marks. They're not saying they're congruent. We don't know that. That was a mistake here. They have arrows. And you can do single arrows, double arrows, as long as whatever you do for one, you do to the other to show they correspond. So they started there. Now, they also mention the next given here, even though we are going to be using statement 1 to get statement 3. You'll see what I mean when I draw some arrows to it. But they say that C is the midpoint of segment AE as well as the next given. Now, there's nothing I can really do with showing that it's a midpoint until I make the statement, until I use it to make the next statement. That's why I said the order's kind of wonky. That's okay. All right, they say that angle BAC is congruent to angle DEC. Here's angle BAC. You could have also just called it angle A, and here's DEC, which you could also just call angle E, but they're saying these are congruent. Why? They said alternate interior. What they're referring to, and they're correct on this, what they're referring to is the fact that there are two parallel lines. We know they're parallel. Two parallel lines cut by a transversal right here. And you're going to have to know this information beforehand from some other videos, whatever. That just focus on the blue, ignore all the black. These are alternate interior angles here, and they are congruent when lines are parallel. When they say alternate interior, they're not just telling you they're alternate interior angles. They're saying this is the alternate interior angles theorem. I tend to write AIA theorem. The theorem says if lines are parallel, if parallel lines are cut by a transversal, then their alternate interior angles are congruent, and that's this. Now they could have also used said and called these ones congruent. Now I'll say that they never do. They don't have to, given what they're going to be referring to here, and that's okay. They don't have to, but they can. They didn't. But it was statement 1 that led to statement 3. Statement 3 is not possible without statement 1. And court case murder things are a lot like that as well. You are going to use previous statements to build on future statements, right? It's not always based on givens pulling out of thin air to connect to a certain point. You might use this point to bridge to this point right here. And that's exactly what's happening there prior to triangle congruence proof. Whenever I see something like C as the midpoint of segment AE right here, I'm inclined by the drawing to then make that connection and say a midpoint is a point right in the middle of a segment that divides the segment to two congruent parts. That's its definition. That's what midpoint does. So I would then draw these tick marks to say, you know what, these are congruent here. That's what a midpoint does. It makes those congruent. And if it makes those congruent, I should document that. And that's what they do right here. Segment AC is congruent to segment EC. They wrote that in statement 4. How can you justify that? That's the definition of a midpoint, baby. That's what a midpoint does. It makes two congruent parts. So I made them congruent. I stated that. Because of statement 2, I can make statement 4. You can see how I'm drawing those. The arrow drawing thing isn't required. This is you seeing how the proof process works here. Okay. Now the next one they said is angle ACB congruent to angle DCE, and that's this one right here and this one right here. And there are a couple things I need to say this. Number 1, they did have to use 3 letters on these. They couldn't have just called it angle C, because there are multiple things you could confuse for angle C. ACB 3 letters, DCE 3 letters. There's no confusion as to what angle A was or E, so I could have said angle A, angle E. But number 2, they're not wrong, and I'll tell you why they're congruent in a second, but they're not wrong in using this order, ACB and DCE. I tend to like to put things in that would correspond, so when I say ACB, I'm kind of seeing the correspondence that I should have said ECD over here, especially if I kind of like made my triangle congruent statement that way. So I'd probably prefer to see ECD. It doesn't matter. That's probably me being really picky. I would never mark a student wrong that way. You would in the triangle congruence statement. It would be marked wrong. Okay, now why are these two congruent? These are what are called vertical angles. Vertical angles are two angles that are opposite each other from two intersecting lines, such as these ones here or these ones here. And the vertical angles theorem is that, well, they're congruent. You could prove it on its own, but we're just going to go ahead and sit with these ones. Vertical angles is going to show up a lot, and they show up naturally in these hourglass figures a lot. And that's why I said you don't need to show these alternate interior angles here. They decided to do the vertical angles route. They got a little diverse in that. I like it. We'll use it. And it leads to enough information. By the way, this was plucked out of thin air. I didn't need to know these lines were parallel to say these were congruent. I didn't need to know this was a midpoint to say these were congruent. I can just use the fact that they're congruent to make its own statement. And going back to midpoint one more time, C is only known to be the midpoint of segment AE. We never were told or given, or we can't assume that C is the midpoint of segment BD. There is no assumption to be had on there. So I couldn't have said, oh yeah, these are congruent too. That it didn't say it was a midpoint of it, right? You could have something that's a midpoint of one segment and totally not a midpoint of the other segment like that. Now you might say, but Mr. Robinson, it wasn't drawn that way. I don't care how it was drawn. We can't assume it's drawn to scale. We're not taking a ruler up to this thing and measuring. I don't care how it's drawn. I'm showing you an exception to the idea that something that's a midpoint of one segment isn't necessarily a midpoint of the other segment. Okay, do we have enough information to show these triangles are congruent? Yeah, we do. We're going to have, and they're correct on this angle side angle case. I don't know. They don't even have a letter F, so I got to change that. We can draw a connection with the fact that these angles were congruent, these segments were congruent, and these angles were congruent here to get an angle side angle case that these two triangles are congruent. Now I got to fix this DEF. It can't be that because, well, there's no F here. So it's clearly not DEF. But if we kept this as ABC, ABC going across this parallel part from the one angle to the two known angles, the vertical angles here. So we got to go EDC right there. We never go across the known tick mark side right there. So we're going to say EDC, triangle EDC right there. So we say that importantly because we got to see which parts correspond. A corresponds with E, B corresponds with D, C corresponds with C. By angle side angle, and because of that statement, of course, we can say the CPCTC route that the corresponding parts are congruent. BC, 2, 3, DC, 2, 3, or 3, 2, doesn't matter. But yes, those are now congruent by CPCTC. That is, this segment right here is now congruent to this segment right here. See, what they could have done is they could have gone even one step further and said, instead of prove this, they could have said, prove C is the midpoint. I'll put MP of segment BD. And what we would have done was said this statement here, CPCTC, and then final statement, C is the midpoint of, and because definition of midpoint again. That would have been interesting. But that's, those are the statements you can lead to. Those are the kinds of proofs you can do, and that's the exact thing that you do use with CPCTC. All right, guys, I spent almost a half hour talking about those three right there. These other, a lot of these other ones we're going to start filling in some blanks for, but now that you've heard a lot of definitions, they can kind of start to go faster, and if nothing new is going to be spoken of, I will be going faster here. Okay, so here we go. Let's actually start to do some of the problems. Fill in the missing information in each proof. And if there's typos, we got to address them. They start easier as the objects are separated. Oh, I'm going to mention, when the objects are separated right here, they probably got to give you a lot more. Because when objects are together, you can see there is a nature of the drawings here that allow us to draw conclusions such as reflexive property, vertical angles, alternate interior angles right here from the parallel lines. That comes to fruition when the drawings are connected, when they have a connection there. But when they're separate, they got to give you a lot more for it to work out. Like this one, number 4. We're given that segment GH is congruent to segment KL. It is not only drawn, but we also have it written right there. And then we're also given that angle G is congruent to angle K. They didn't draw it for us, so let's go ahead and draw it there. And it looks like it's the undocumented statement. So let's do that. And then segment GI is also given to be congruent to segment KJ, and that is its reason. It is given to us, both drawn and told. We have 3 pieces of information that we can actually draw a conclusion to state these two triangles are congruent, which is what we kind of want to do next. Our final statement in this proving statement, I'm going to tell you right now, it's a CPCTC thing. We want to prove that if these two triangles are congruent, then those corresponding parts must be congruent. So let's go ahead and do a triangle congruent statement. Maybe we call this thing triangle HGI. Triangle HGI. And if we're calling it that, then the other triangle needs to correspond its parts such as LKJ. And I hope you're getting used to why these parts correspond the way they do, especially when you see me navigate it. 1, the 1, the 2, the 1, the 1, the 2, like that. So do those parts correspond right here? Because here's the thing. They're not always going to be all pre-filled out for you, right? You have to create things on your own. Would you be able to make that connection here? HI, first and third letters. LJ, first and third letters. Yes, because the triangles are congruent, because those parts correspond. Corresponding parts of congruent triangles are congruent. CPCTC, that is our proof. And use the drawing to do exactly what I'm doing here, which is mark it up so you can figure out what's supposed to go where. Given angle MNP is congruent to angle OPN. MNP is this angle right here. That is congruent to angle OPN. That's this angle right here. They give it to us. They mark it. Let's document that as the first given that seems to be missing for us. Given that segment MN is congruent to segment OP, also marked for you guys, and first of all, I would have probably put PO, what I was talking about from before, but that is also given But also, they're not always going to mark those things up for you. Maybe on this sheet, but in general, in some proofs, they're not always going to mark those things up for you. So make sure you know how to mark them up after. And this one's not marked here, which says NP is congruent to NP. Once again, this is the reflexive property. This is a shared side that says it's congruent to itself. But more importantly, it's our way of saying that one side in one triangle is congruent to the other side in the other triangle, just by the nature that it is indeed shared. Now, once again, and I probably should have said it for this other one too, I kind of want to reverse this and call it Pn. See, unlike that previous triangle that we looked at, this isn't a reflection of one triangle in another like this. This is a rotation of another triangle. That's why I kind of want to put PO here as well. It's not wrong what they put. No, I'm sorry. OP is actually good that they put MN and OP. That's a good one. I apologize for that. I was thinking PO in my head. But I would have put PN. NP in this triangle is congruent to PN in this triangle. Right? It's the way that they rotated it there. They even show it as such here. Triangle MNP and triangle OPN right here. Notice how NP is the second and third letter. PN is the second and third letter. Notice how they have it swapped there, as they need to, in the triangle congruence statement. And now that reason here, if you notice the sequence here, we got side angle side and side angle side right there, connecting those ones. That is a side angle side relationship. Those triangles are congruent. That's enough information. And finally, the last statement is the proving statement. Segment MP, therefore, must be congruent to segment NO by CPCTC. MP is right here. NO is right here. And I probably, again, would have said ON. But by CPCTC, they are also the first and third letters right there. Okay, number 6. Told you it was a little bit faster. Or maybe it wasn't. I don't know. Hang on. Let me fix all that I'm trying to do. I'm trying to move myself. Hold on. Oh, no. I gotcha. There we go. Sorry. A little finicky. Speaking of which, let me lock that. There we go. All right. Number 6. Rookie mistake. Given segment ST is congruent to segment VU right there. That is totally given. This is once again one of those things, guys. I'm feeling they're missing something. They have to tell us somewhere here, and I'm gonna write it. This is part of our statements. It's gonna wedge right in between. It's given by marking, but we didn't write it, and we really should have. Angle S and angle U are right angles. Now, it's not required to mention that they're congruent if you're going to be using HL, which is actually what we're going to be using this time. But they are right angles. You could say that that's given because it's through the marking. You could say that that's given because the marking's right there. That they are right angles here. That's important. Or you can say that the triangles are right triangles. Either or. You're going to have to make some mention here, because if we're going to use HL, hypotenuse leg is a congruent statement, only exists in right triangles with right angles. And what we're about to say in this other one here by reflexive property, as statement 2, is something we're going to come up with on our own, that this triangle, this TV and VT are congruent to each other here. TV in one triangle is congruent to VT in the other triangle. We have an angle side-side case, which is generally not enough to make right triangles congruent. But this TV, VT thing, this is the hypotenuse of this right triangle and the hypotenuse of this right triangle here. The hypotenuses are congruent in both right triangles. That one set of legs is congruent in both right triangles. That does make these triangles congruent. I can call this triangle, I could say like VST. Triangle VST is congruent to triangle, I said VST, so I have to say TUV in this triangle right here by HL. But that's only possible using this one as well. I need to say right angles or right triangles, right? I could say this was given. I didn't write that. I could say this was given. And then I could say that this and this are right triangles by definition of right triangles, because they're right triangles with right angles. And then I get into there. Anyway, now this gets into CPCTC, saying that these two angles here are congruent. SVT, and UTV right here are congruent because they are corresponding parts. Notice that they are V and T are both the second letters. No, I'm sorry. They're both the, well, they're the first letters here and the third letters here, the V and T and such. They are corresponding parts in their own respective triangles there. This is CPCTC. Okay. Number 7. Given segment AC is congruent to segment CE, boom, boom. Given segment DC is congruent to segment BC, boom, boom. They're going to prove angle B is congruent to angle D. Let's prove the triangle's congruent first. Looks like they're going for ACB and DCE by vertical angles right here. These two angles are congruent. I say they are. That's something we want to do here as well. Remember, we got to go on the hunt. We have two sets of sides congruent. Two sets of sides is not enough to prove that two triangles are congruent. We need to also get a third set of sides, which I don't see a way we can do that without givens, and or a set of angles. And it looks like the vertical angles are the ones that are sticking out in our faces there. The vertical angles theorem tells us that exactly. That's enough information now. We have a side angle side case, to show that triangle ABC is congruent to triangle. See, they say DEF again. There is no F here. That's the same thing as before. ABC is congruent to triangle EDC. It looks like one that we've already kind of done before, right? Triangle EDC, because of, again, it's side, angle, side right there. This is the side, angle, side congruence thing. And angle B is congruent to angle D. Notice that B and D are the second letters in both of these ones right here. That makes another CPCTC bit because the triangles are congruent. There we go. That one a little bit faster, even with the mistake that they had. All right, maybe some new stuff to talk about right here. Ooh, I know something that's new. Given GH is parallel to segment JI, so GH and JI have our arrows right here. That is a given. Given that point I is the midpoint of segment HK, it's maybe a comma, and then segment GH is congruent to segment JI. So these segments are not only parallel, but they're also congruent. So that would be that one here. Now, this one is given, but also when the midpoint statement is made, it's probably good to say what a midpoint's going to kind of do for you. If I is the midpoint of HK, then it divides HK into two congruent parts with HI and IK. And that's probably, yeah, so this statement they're going to make right here is because of statement 2. Because of statement 2, I can make statement 4 there, right? HI is congruent to IK, that's the definition of a midpoint. But def of MP right there. So that's the idea. The midpoint allows that to happen, and we get those congruent parts. Now, they're going to talk about corresponding angles right here, and they're going to talk about angles that we can call congruent in both triangles. Corresponding angles are angles that are kind of facing the same direction. We've already talked about things that correspond in different ways, but I'm talking about when two parallel lines are cut by a transversal. We know that these lines here are parallel. And that makes this angle congruent to this angle here. You kind of see that facing the same direction nature. This is what is known as the corresponding angles postulate. So I can say that this angle H is congruent to this angle I. I'm not just going to call it angle H and angle I and use 3 letters, but that's that idea right there. That's what they're going to use the parallel lines for. We're going to be using that statement 1 to build this statement 5. It's kind of a weird way of going back to that documentation where the judge is like, wait a second, why did you were going to convict him of murder and you first started talking about he was hired as a clown when he was a kid. Why does that connect? Oh, Your Honor, I'm getting right back to that 2 hours later. Let me tell you about it. You see, because he's the clown killer. All right, so because these two lines are parallel right here, you know what? I can call this one angle H. I could say, literally, this would be weird, but angle H is congruent to angle JIK. I think IXL does that kind of stuff. I tend not to, but angle H, there's no confusion as to what that one is, but angle I could have been this angle, this angle, this angle, this angle, the whole thing, whatever it is. So I'm going to call it JIK, and of course I want to mark that here. Those are corresponding angles. That's the corresponding angles postulate. That's enough information right there. I got a side angle side case here, side angle side, to now show that these two triangles are congruent to each other. I can call this triangle GHI. They kind of face the same direction here. JIK is congruent to triangle JIK. And they tell us as well, that's side angle side here. G and J are first letters in both of these. They correspond. They are congruent. That is CPCTC. Okay, number 9, and then we're we're more than halfway done. This thing's going to take an hour 20 to finish, but given the ones we had to fill out, there's a whole nother 6 problems on this other side that I'd like to do. All right, given segment MP is congruent to segment NP right here, and here we go. Here's a perpendicular symbol. Segment MN is perpendicular to segment OP. So first of all, here's the congruence segment. Here's the congruent segment statement that I'd like to make right there. That's the first given. Now we're showing that it's given these are perpendicular, but you might want to say something off of that. Again, they're missing stuff here. If they're perpendicular, what does that mean? It means you have right angles. I want to see where they're going with the, well, I do know they're right angles. That makes them right triangles. Again, I'm telling you things. I can't really write it here. It's not missing. We've used up a lot of time. Perpendicular lines means right angles. Right angles means right triangles. Right triangles means HL potential because these are now hypotenuses. You see that lead-in though? That's the lead-in. You may or may not understand that lead-in is necessary, but you also need to understand it needs to be documented. The fact that they're not documenting it's something I'm not a fan of. There are some proofs that choose to skip those steps, and I get it because we can make those implied connections. But to what end do we stop making implied connections? Everything in court needs to be hard evidence submitted, documented, and presented in such a way that it's there. It's actually there. Anyway, so going back to this, OP is congruent segment to is a congruent segment to itself, and as this is more of a reflection than a rotation, it appears that putting this OP and OP is probably the way to do it. That's the reflexive property again. And as I say reflexive property, I'm not saying reflective property. Not the same thing. Reflexive property, different. Triangle MOP is congruent to triangle NOP. Indeed, we have not angle side side, but we have HL. We have two different right triangles, which again, we didn't document it, but we have two different right triangles here with the congruent hypotenuses and congruent set of legs there. That is the HL congruence theorem. Lastly, we got to prove that segment MO is congruent to segment ON. That was MO and ON right here. That is CPCTC. If you look at MO and ON, they are the first and second letters respectively. I know they probably should have said NO. That's what I would have done. But that is CPCTC right there. And again, that's something where you could say, therefore, O is the midpoint of segment MN and things like that. Actually, that's a good, I'm not going to talk about it. I was going to say that's a good case to make to talk about how an altitude bisects an isosceles triangle. The segment in an isosceles triangle. Okay, here we go. Given this is one of those right angle things, so you're going to have to apologize. It looks like they're consistently going to do that. Segment SU is congruent to segment VT as marked. It is given. They want reflexive property out of this, but okay, so these are given. Angle STU and VUT are right angles given. These are right, it's given there. And then these are right triangles by definition of right triangle. We're going to have to accept that. It's not there. We're going to have to accept it's that. They want us to talk about the reflexive property right here that segment TU, say in this triangle, is congruent to segment UT in this triangle. Right, segment UT, and if this time I do put it the other way, that is the reflexive property at play. It's a shared side in both triangles. Given the right triangle bit, this is another HL case of two legs that are congruent to each other, two hypotenuses that are congruent to each other. I can call this triangle, let's say STU is congruent, triangle STU, it's congruent to triangle VUT, like that. Sounds good. Therefore, segment ST is right here, is congruent to segment UV, ST. I would have said VU, but that's okay. Segment ST is congruent to segment UV by CPCTC. So you can see where, oh, I'm sorry, I was blocking you for some of that. My bad. I didn't change my picture thing, but there's the bottom portion. I'm very, very sorry. You can see that these can be, they can kind of seem same-ish. They can. Or at least some of the repeated patterns. Same with murder. That can seem kind of same-ish sometimes. Why do they keep doing murder then? I do not know. But anyway, so you can see where this keeps going, and it just gets you more comfortable as you keep doing it. All right, given we have parallel lines right here, A, B, and D, E. segment AE bisects segment BD. Now this is an interesting case. We haven't seen this phrasing yet. We've seen something being a midpoint, but not being a segment or angle bisector. So a segment bisector, by definition, intersects another segment at its midpoint, which is kind of nice to say. And I say by definition because we're going to use its definition here. AE intersects BD at its midpoint. So BD has a midpoint called C. Okay, that's something we're going to get into there. BD is a midpoint called C. BD doesn't necessarily bisect AE unless they mention it, which they didn't. This is the subject, this is the object. Okay, so segment AB is parallel to segment DE. That's given. AB is parallel to DE. That's given. My capital G's are getting bad. It's also given that segment AE bisects segment BD. Okay. Angle ABC is congruent to angle EDC. Now they went for ABC, EDC right here. This was, if you were with me earlier on some of the other things, these are alternate interior angles that are only congruent because these lines here were parallel. If they weren't, that wouldn't have been the case. So because of the statement, thank you, we can make that statement. That is the alternate interior angle theorem. And then ACB congruent to DCE. I'm sorry, this is a 1 arc mark right there. Let me fix that. ACB congruent to DCE. Once again, I probably would have said ECD there. So they went, instead of going the alternate interior angles here, they went for the vertical angles. Either or is fine, but they went for the vertical angles here. Vertical angles theorem. Number 5 is the definition of bisector portion. So we're going to use the definition of bisector to make a statement here. If this segment bisects this segment, then this segment is intersecting the segment at its midpoint. That means C is the midpoint of segment BD, which means this is bisected into two congruent parts right here. We want to say that segment BC is congruent with segment DC right there. Segment BC is congruent to segment DC. That is definition of segment bisector. We don't know that BD bisects AE, by the way. Okay, and lastly, well, not lastly there, but now we have an angle, side, angle case, angle, side, angle, that these two triangles are congruent to each other, ABC and EDC. They actually got that one right this time, by angle, side, angle, right there. And that leads to the final statement that apparently AC actually is congruent to segment EC by CPCTC. They are corresponding parts. Take a look at where they fit. AC, first and third letter, EC, first and third letter, by CPCTC. Those are corresponding parts and congruent. I'm not drawing all arrows for everything, by the way. I could have to do all the connection things. I really want to show how the givens are leading to things, especially if you have to skip a step to do it, or 3. I really want to show them then. Okay, this time I got to promise to move myself, as we have, I think, four more problems to do, and that's it. I'll finish within the hour. I can't promise that. If 12 minutes, 3 minutes a problem, we'll try. Is there new information? We'll see. Given segment GH is parallel to segment IJ, GH is parallel to IJ. Given angle H is congruent to angle J. And given GH is congruent to segment IJ. So they're both parallel and congruent right there. All of those 3 are told and marked. All right, we're using parallel lines to use. They mention alternate interior angles. I'm going to state right now these triangles do not have alternate interior angles constructed, of which I can see. I do see, well, they do have them. For instance, this is congruent to this, but this isn't an angle inside the triangle. What you want to find are angles that are congruent inside the triangles to work with. So I'm going to go ahead and cross this one out. This isn't one that I want to use here. I see 2 parallel lines here, and the only transversal I can find that it has angles that exist inside both triangles is this one, which means I can construct these angles congruent right here and here. Those aren't alternate interior angles. Those are corresponding angles. So I can call this angle G, for example, and I think I did this before. I can call this angle JIK. And those are corresponding angles, not alternate interior angles. It's sad when I have to fix a worksheets problem that has things filled out. It's even sadder that I am choosing to blame a worksheet when I could have made one on my own or fixed it before the video. Okay, so number 5 here is going to be the congruent triangles statement here, which can be, which can be an angle side angle case. We have enough information. Angle side angle, or angle side angle here. Angle side angle. Triangle HGI. I can call it triangle HGI. Congruent to, say, triangle JIK by angle side angle. And lastly, that's enough information to say that angle GIH, we never mentioned anything on this one, angle GIH therefore is congruent to angle IKJ by CPCTC. Angle G, and I'm talking about this right here. Angle G, the last statement should be your proving statement. It's congruent to angle IKJ. Once you prove the guy guilty of murder, what else are you trying to prove after that? Unless you are trying to prove something else after that. Maybe the murder is just the least of their worries. Therefore, he's a bad man, Your Honor. Seems guilty. All right. Given. They're really missing out on a lot of things here. Segment PM is parallel to segment NO. Now, here's what I don't like off the bat. They put the arrows, that's nice, but they should probably put singles on one of them and doubles on another. I mean, I know to the uninitiated, to the initiated, it's plainly obvious that lines that intersect can't be parallel to each other, so there's no way to do it. But you shouldn't be confusing your audience for when it actually will matter. Single arrows on one set, double arrows on the other set right there. So PM parallel to ON, and then after that we do have MN parallel to ON. So both are given on that front. Looks like they are going to attack alternate interior angles here now. First they lead to angle PMO, that's this one right here, congruent to angle NOP, that's this angle right here. Those are alternate interior angles as a result of which parallel lines, by the way? If you look at the first statement, PM parallel to ON, that's those ones that's creating those alternate interior angles there. So it's actually statement 1 that led us to statement 3. Let's see if we can use statement 2 to lead us to another set of apparent alternate interior angles. How can MN and PO create alternate interior angles? I'd say it's these ones right here. Right here we can say angle NMO, angle NMO, congruent to angle NMO, POM, angle POM, right there. Those are also alternate interior angles from statement 2. Statement 5 is MO congruent to itself. That should be the reflexive property right there. You know I'd rather probably put OM on one set. Reflexive property. And again, it's more because it's a rotation more so than reflection, and you'll see in the corresponding parts. That is indeed an angle side angle though. Angle side angle, angle side angle. Hopefully see the two different triangles there. If I called this one PMO, triangle PMO, then I would call the other one NOM, or triangle NOM by angle side angle. That should prove that segment PM is congruent to segment ON. Let's see. PM congruent to ON. I would rather say NO. But because, listen, we only knew they were parallel. We didn't know they were congruent. Well, now we do. Because they correspond as parts, the triangles are congruent, therefore they are congruent CPCTC. Again, if you're practicing triangle congruence, guys, this last statement I'm making is not really much for you to need to pay attention to for now, but it is for later. And it's nice to say this is why we prove triangles congruent. It leads to future steps, not even just the CPCTC step. I'm potentially on pace to finish on time. Let's see. These segments, especially now to fix their problems. Speaking of problems. I don't know what that's doing there. All right. Segment ST is parallel to segment WV right there, given. Segment ST is congruent to segment, now suddenly they call it VW. Honestly, I would have called it WV. Segment ST is congruent to segment VW. Let's just go with what they put. Alternate interior angles? Sure. You know, we actually have one of two different sets. This is your choice. Now, before I do that, I want to make sure they didn't call these alternate interiors. They didn't. They went for the vertical angles here. I'll get back to number 3 in a second. This is number 4. Number 4, they have angle SUT congruent to angle WUV, and I like the order they put those as well. Those are vertical angles. So we actually have our choice of alternate interior angles you'd like to work with. Would you rather, because these are your two parallel lines. We have two different sets of transversals. We either have this transversal to call these two angles congruent, or we can call these ones congruent here by that transversal. It doesn't matter. And since this is the last one I haven't erased, I'm just going to use these ones here. I'm going to say angle T is congruent to angle V. And there's no confusion as to what is angle T and what is angle V. So I can go straight into that. So angle T is congruent to angle V by alternate interior angles. Much the same I could have said angle S is congruent to angle W. Doesn't matter. And it still doesn't matter because as I need to do angle, angle, side, this still would have completed that angle, angle, side sequence just fine. I could have completely ignored the vertical angles, but they gave them to us. So triangle, let's call it STU, is congruent to triangle WVU by angle, angle, side right there. And then lastly, that should lead us with segment SU congruent to segment WU. There's no angle symbol there. Segment SU congruent to segment WU by CPCTC. That's that last part they want to kind of put in once the triangles are shown to be congruent using angle, angle, side. All right, I should finish here. We got one more to go. And having these connected actually seems to mean nothing to us unless they were trying to tell us, hey, look, they did the thing that I was doing before. You don't need to use three letters if you don't need to, and then you do when you do. Having these connected means nothing for us, as they didn't mention anything about midpoints, parallel lines, or anything like that, but they are connected. This is actually an easier problem than a lot of the other ones we did before it. If I was covering you the whole time, I really apologize. Why don't you keep that on there for a moment? My bad. It's been rough. Okay. My bad. Keep that there. Okay, last one right here. Segment AB is congruent to segment CD. Segment AB is congruent to segment CD. Boom. Given. Segment BC is congruent to segment DE. Also given. Given, segment AC is congruent to segment CE. Triangles are congruent by side, side, side. We haven't seen that in a while. Let's call it ABC. Congruence triangle by ABC, CDE. By side, side, side. Lastly, that leaves angle A congruent with angle DCE by CPCTC. It's good to end on a really easy one, apparently. And you can't see what I'm writing there. I just totally realized. Whoops. I just totally realized that. I'm messing a lot of things up right now. I just messed up my microphone here as well. Really apologize on all this marking stuff right now, guys. I don't need my face in the picture. You don't need to see me. You need to see the work that's going on. So I'll leave that there for a moment as I just keep talking through and concluding. This is the last page that I'm on. So yeah, in conclusion here, if you're understanding what's going on, we are documenting evidence and building a case to prove something. We have to justify every statement that we make with some sort of reason. Some of the vocab is stuff you're gonna have to know. Otherwise, you could probably explain it. There's no one stopping you. It's just keeping it shorthand is something that universally we understand in geometry that does make it legible and, brief. Like the reflexive property, vertical angle, things like that. We can work off of those things. But yeah, you don't make things up. There's no guesswork here. There's no maybe he's guilty. I mean, I don't really know. Just look at him, right? Yeah, you can't just look at something. And for some things, there is enough information to make something true, like the side cases, things like that. It actually is enough to go off of. CPCTC is a whole new brand after that. That wasn't a huge talk on today's thing because of really what CPCTC can lead to. That would be a better talk for later. I'm sure I have some videos covering that a little bit. But guys, that ought to do it for this one here. This is Mr. Robinson. Thank you so much for watching. I really apologize at the end there for covering things up. I hope that did help. I will surely see you in the next one. Take care.